All right, accounting students, welcome. For any company that makes and sells actual physical products, one of its biggest headaches and biggest costs is shipping. So today we're going to dive into a really powerful tool from a field called operations research that tackles this problem head-on. It's called logistics optimization, and it's all about turning a massive, complicated shipping puzzle into a clear, solvable financial problem.
Okay, let's jump right in with the big question, the one that every large company has to answer. Just imagine you've got dozens of factories and maybe thousands of stores. Every single day you have to figure out what to ship from where to where. Now, getting this wrong, we're talking millions of dollars down the drain. But getting it right? Well, that's where real financial strategy and real savings begin.
So here's our game plan. First, we'll talk about why shipping is such a high-stakes game. Then we'll deconstruct the problem into its key parts. After that, we'll see how these models adapt to the messiness of the real world. Then, the fun part. We'll see how to solve a problem using Excel. And finally, we'll wrap up with why this all really matters for you as a financial professional. Okay, first up, the high-stakes shipping game. So, why do we call it that? Well, because we're not just talking about moving boxes around from point A to point B. We are talking about something that is absolutely critical to a company's financial health. So what is this thing exactly? You can think of logistics optimization as a structured way to solve this huge distribution puzzle. And the keywords you really want to focus on here are optimal allocation and minimum total cost. It's not about finding a good plan, it's about finding the single best plan out of literally millions of possibilities.
It's really all about this delicate balancing act. See, on one side, you have your supply, everything your factories can produce. And on the other, you have your demand, what all your stores need. You've got constraints, right? You can't ship more than you have, and you have to meet the demand of each store. The whole goal is to keep this scale perfectly balanced while making sure the cost of doing it is as low as it can possibly be.
All right, so to solve any puzzle, you first have to understand its pieces. So let's deconstruct this thing and look at the basic building blocks. First up, you've got your sources, or supply nodes, if you want to get technical. Just think of these as the starting points, your factories, your warehouses. The most important thing to know about a source is its capacity. It has a hard limit on how much product it can supply. And then on the flip side, you have your destinations, or demand nodes. These are the endpoints, the retail stores, the distribution centers. And their defining feature is their requirement, right? Each one needs a very specific quantity of goods to be delivered. And what connects all of this? The routes, of course. Every single path from a source to a destination is a unique route. And here's the kicker. Each one has its own specific cost per unit. So shipping a box from Denver to Dallas might cost you a different amount than shipping that same box from Denver to Seattle. It's these varying costs that make the problem so complex and interesting to solve. And here's the cool part. When you put all those pieces together, all your sources, all your destinations, and all the possible routes connecting them, you get what's called a network. And suddenly, this giant abstract problem becomes a visual map that you can actually analyze and solve.
Okay, that all sounds pretty neat and tidy, right? But we all know the real world is anything but. It's messy. So how does a clean, perfect model like this actually handle the messiness of reality?
Well, it all comes down to one key difference. Is the problem balanced or unbalanced? You see, in a perfect world, your total supply would exactly equal your total demand. But let's be real. How often does that happen? More often than not, they don't match up. And the great thing is, the model is smart enough to handle this. So how does it do it? It's actually a pretty clever trick. If you have way more supply than demand, the model creates a dummy destination that basically just absorbs all that excess inventory on paper. And if your demand is greater than your supply, it creates a dummy source to represent that shortfall. It's a smart way to balance the equation so the math can work, and it gives you a crystal clear picture of your surplus or your shortage. And get this, it's not just about cutting costs. That's what's so powerful here. You can flip the entire logic on its head. Instead of minimizing your shipping expenses, you could use the exact same framework to maximize things like profit or sales by telling the model to send goods to your most profitable locations first. All right, the theory is cool and all, but how do you actually solve one of these things? Well, let's talk about a tool you probably already have right on your computer, Microsoft Excel, and a feature called Solver. You know, the process in Excel's Solver is actually pretty straightforward. First, you just lay out the problem, your costs, supply, demand, all that. Second, you set your objective, basically telling Solver, hey, I want you to make this total cost cell as low as possible. Third, you point it to the blank cells that it's allowed to change. Fourth, you add your rules, your constraints, like don't ship more than this factory has and make sure this store gets what it needs. Finally, you just select an option called Simplex LP, which is just a fancy name for a proven algorithm, and you click Solve. And boom, just like that, Solver does all the heavy lifting. It crunches all the numbers and populates that empty table for you. What you get back isn't a guess, it's not an estimate. It's a precise, data-driven shipping plan that tells you the exact number of units to send on every single route to get the absolute lowest possible cost. Okay, so let's bring this all home. Why should you, as a future financial manager, really care about any of this? Why is this so much more than just a logistics puzzle? You know, in the world of logistics, people talk all the time about the 3 rights. Getting the right quantity of goods to the right destination at the right time. Well, effective optimization is exactly how you achieve that. Hitting all 3 of those targets consistently is the absolute foundation of an efficient, reliable, and, most importantly, profitable supply chain. So here's the bottom line, the big takeaway for you guys. This is not just an operational tool for the warehouse manager. It is a strategic framework for you. It gives you a quantitative, rock-solid, defensible basis for making huge financial decisions about how a company uses its resources. It completely takes the guesswork out of one of the biggest line items on the income statement. This way of thinking, setting an objective, defining your variables, and working within your constraints, it is an incredibly powerful way to solve problems. So I'll just leave you with this question to think about. Now that you have a framework for optimizing a shipping network, what other complex financial problems, things like budget allocations or even investment portfolios, could you attack with this exact same powerful logic?